top 10 crazy tools equipped on the Curiosity rover. To preserve evidence about whether Martian life ever existed in the past or does so now, it's important to look for hints about environmental factors that are conducive to microbial life. Curiosity, the most recent Mars rover, is part of a robotic line of explorers developed by scientists and engineers, each of which built on the accomplishments and shortcomings of earlier rovers. The Mars Rover Curiosity is comparable to earlier rovers. However, it is the most sophisticated rover yet, and the tools it will use to study Mars will provide us with new levels of understanding. Are you curious to know about some bizarre tools on the Curiosity rover? Then continue to the end of this video. The Curiosity rover from NASA is currently exploring Mars's surface in search of life signals and gathering information on the planet's distinctive environment. The rover has traveled 17.64 miles as of August 2, 2022, 2839 kilometers. The spacecraft used a parachute to descend before the landing system fired up its rockets and hovered as the rover was lowered down onto the surface. The rover is a part of NASA's Mars Science Laboratory mission, which tested a revolutionary landing procedure. The Perseverance rover touched Mars in February 2021 after undergoing a similar entrance and landing procedure. The powerful instruments installed aboard the Curiosity rover to aid researchers in understanding Mars secrets will be discussed in this video. This video also describes each of the top 10 most powerful tools in depth, including its primary function and how it will help future Mars exploration. Please give this video a thumbs up and subscribe to this channel for more just like before we continue. Click the bell icon to receive notifications of new videos. Did you do that already? Let's start. Number 10. A detector for radiation assessment. Radiation doesn't bother Curiosity all that much, but the humans NASA hope to send as explorers to Mars in the future may be a little pickier about the goods. Therefore, the Radiation Assessment Detector, RAD, plays a crucial role as one of the few pieces of equipment deployed to Mars to prepare for human exploration. The instrument, roughly the size of a tiny toaster, will peer into the Martian atmosphere and monitor cosmic rays and solar particles, using a stack of silicon detectors and cesium iodide crystal. The RAD can measure the energy of charged particles by measuring the electron or light pulses produced as the particles pass through the detectors after entering the atmosphere. The procedure may also reveal further information about how radiation may have once prevented the emergence of life on Mars. Number 9. Mastcam Device. Mast camera, commonly known as the Mastcam, is undoubtedly the most sophisticated. Curiosity will capture color photos and videos on board and be able to stitch the photos together to produce stunning panoramas of the canyon landscape on the Red Planet. It features high-resolution lenses and can take HD video at 10 frames per second. The analysis of light patterns in various regions of the electromagnetic spectrum using single-color photographs capture the monochromatic environment. It contains a lot of data, but an internal data buffer allows it to store thousands of photos or hours of HD video for transmission down to Earth. Number 8. MEDLI. The 7 minutes of horror video from Curiosity's engineers suggests that engineers have much to worry about during the rover's descent through the atmosphere. However, Curiosity will already be busy collecting data for the upcoming Mars missions as it descends. The heat and pressure it experiences during entry will be monitored by the MSL Entry, Descent and Landing Instrumentation, MEDLI. It consists of two instruments, MEDS and MISP, MEDLI Integrated Sensor Plugs, Mars Entry Atmospheric Data System. On the heat shield of Curiosity, there are 7 of each type. On the left of the picture, the system is in the black box. When burning through the atmosphere, MISP will measure how hot things get. Short response, really hot. A much longer response is that it is 3 times hotter than a space shuttle traveling through the atmosphere of Earth. The thermal protection mechanism on Curiosity will degrade, and MISP will track this, rotation and burning rate. During descent, MEDS will measure the atmospheric pressure. The 7 sensors, arranged in a cross pattern, will enable engineers to estimate Curiosity's direction over time. Once they know that, they may compare Curiosity's descent to their projections and revise them. Number 7. ChemCam. To carry out its mission, Curiosity relies on the most advanced suite of instruments ever sent to the Martian surface. among them a laser firing tool called the ChemCam, a concept originally developed at the Energy Department's Los Alamos National Laboratory. ChemCam serves two key purposes: determine whether rocks and soil on Mars contain chemicals necessary for life, and identify rocks and soil for analysis by other instruments aboard the rover. ChemCam is a multi-partnership effort between Los Alamos, the French National Space Agency, Centre National d'Études Spatiales, and French research agency Centre National de Recherche Scientifique. So how exactly does ChemCam work? At the instrument's heart is a high-powered laser, capable of focusing more than 1 million watts of power onto a pinhead-sized area for 5 billionths of a second. The process works in a straightforward manner. First, ChemCam fires its short laser pulses at a target, Martian rocks or soil, with pinpoint accuracy. Then, once hit by the laser, electrons within the target become excited, emitting light. Next, ChemCam uses a built-in telescope to capture this light, sending it down an optical fiber to the body of the rover. Finally, a spectrometer on board the rover reads the light, identifying the types of alarms within the target. By revealing which atoms are present, ChemCam accomplishes the vital task of informing scientists of a target's composition. Beyond its laser, ChemCam also makes use of a high-resolution camera, powerful enough to view a human hair from 7 feet away, providing scientists with an extremely detailed image throughout the Mars exploration. Number 6. Hand lens imager. Sometimes technology developed by common people can compete with that of an uber geologist like Curiosity. For instance, a significant and frequently employed geological tool is the hand lens, and the Mars rover will have a robotic equivalent on board. The Mars Hand Lens Imager, MEDLI, will assist in providing scientists at home with a close-up look at samples. MEDLI can capture color images at a distance of as little as 12.5 micrometers. It will be able to operate day and night using a typical white flashlight type source and an ultraviolet black light source. Further use of UV light is to illuminate samples to find carbonate and evaporite minerals, which would indicate that water played a role in the formation of Mars. Number 5. The Environmental Monitoring Station at Rover. The Rover Environmental Monitoring Station, REMS, will enhance Mars Rover Curiosity's abilities as a brilliant geologist and great cosmic meteorologist. In daily and seasonal reports, REMS will provide scientists with data on atmospheric pressure, humidity, UV radiation, wind direction and speed, air temperature, and ground temperature. 2 booms will measure wind speed to better comprehend breezes and dust, one of Mars's most significant meteorological phenomena. A filter seals out all the undesired dust, while a sensor within that is exposed to the ambient records, variations in pressure brought on by change in the weather. Number 4. Alpha Particle X-ray Spectrometer. To get an accurate analysis of samples on Mars, the Alpha Particle X-ray Spectrometer, APXS, works closely to obtain an accurate study of samples on Mars. The element curium placed inside decays when it touches rocks or soil samples, bombarding them with alpha particles and X-rays. The rays dislodge electrons from the material, and sensors can detect the energy released. With this much power, you have sodium. Recount the number and you will have something else. It operates day and night, but a full analysis can take up to 2 to 3 hours to identify every ingredient in a sample, even if 10 minutes is more than enough time to quickly identify the key components. Number 3. Chemistry and Mineralogy X-ray Diffraction Instrument. The goal of Curiosity's mission is to learn more about Mars's past and advanced space technology. Minerals can provide a clear picture of the planet's appearance during its formation. For instance, certain minerals may show that lava formerly flowed nearby. ChemIn, an instrument for chemistry and mineralogy X-ray diffraction, will be able to locate and examine all of those things and much more. Drilling into rocks will enable Curiosity to gather powder that may store inside. When small X-rays from ChemIn interact with the rock or soil sample, some are absorbed and re-emitted at varying energies. ChemIn can identify the atoms in the sample by computing their energies. The minerals they find may also provide a signal as to how significant the part water plays in the formation of the planet's minerals. Chemin can distinguish between minerals that contain water and those that don't. It might even reveal to scientists whether life could have once existed on Mars. Number 2. The Sample Analysis at Mars Instrument. Its technological titan is the Curiosity Mars Rover's Sample Analysis at Mars SAM instrument. It's a group of 3 instruments that accounts for more than half of Curiosity's scientific payload, and it's focused on finding signs of life on Mars. The instrument's gas chromatograph, turntable laser spectrometer, and mass spectrometer can discover carbon-based chemicals like methane, while looking for lighter elements like hydrogen, oxygen, and nitrogen that could also be signs of life. The gas chromatograph uses heat to vaporize samples for analysis. The mass spectrometer separates elements based on mass, and the laser spectrometer counts the number of different isotopes in the samples. Accurate to within 10 parts per thousand, it may be the best chance Curiosity has of discovering life, past or present. Number 1. Dynamic albedo of neutrons. There are ways for Curiosity to find water on Mars even if it doesn't run into a puddle. Neutrons are often thrown out of orbit by cosmic rays striking the planet's surface. These neutrons will be slowed down by hydrogen atoms in water or ice, and this can be seen. Water content as low as 0.1% can be found using the dynamic albedo of neutrons, DAN, a pulsing neutron generator. Many slower neutrons are a good indicator of water beneath the surface. Thus, DAN will shoot a beam of neutrons 3 to 6 feet into the ground. There is still much for us to learn. The existence of life or any evidence that it ever did on the red planet, the location of its water, and the composition of its surface are just a few of the many unresolved mysteries that remained. Therefore, engineers and scientists have spent no expense ensuring that Curiosity has the tools to inform us about our planetary neighbor. We have to come to the end of this video. Do not forget to give this video a thumbs up and subscribe to the channel to see more content like it. Do not forget to click the bell button to receive notifications when new videos are posted. Till the next video, bye for the moment.